Alright, so this is exercise 1K on page 65 of your textbook. Alright, compound interest. So we've talked about simple interest, compound interest. What's the difference? Compound interest, and I'm reading this point over here. Compound interest is interest which is added before the next amount of interest is calculated. Now, that's just a bunch of words. So let's go ahead and try and describe it as we would with simple interest. So imagine I've got this here. This being your Y value being your bank account, so the amount of money in your bank, so that would be in dollars. And then on the bottom, the x-axis, I've got time. So let's say that's years. Let's say that's per year. Okay, so you start off with this amount of money. Let's say that's $100. So 100, apologize for the tiny handwriting. Let's say that's $100. I start with $100. Now I need to, let's say I'm talking simple interest. So if it's, for example, 10% every year, if it's 10% every year, I'm increasing by $10 every year. So let's say I'm increasing by my amount, it increases like that. Actually, let's draw it a bit straighter. There we go. That's my simple interest, right? I'm increasing by the same amount every single time. Now, the interesting part is, most of you guys actually already have bank accounts, and for those of you who are paying attention, you might notice that the interest is actually calculated, well, first it's calculated per month, but let's assume it's per year. It's actually calculated considering how much money you already had in the account last time. So the first time, let's use green for our compound interest. Compound interest. Now, it's still going to be the same rate, 10% every year, but it's increasing more and more and more and more, depending on how much money you have in your account. So instead of being a straight line like our simple interest was, it's going to curve like this. Oops. Like that. So you can tell this is a curve, right? It's a curve versus a simple interest, which is a straight line. So over the same period of time, let's say, for example, let's say I'm looking at this many years. Let's say it's increasing. I've got this many years, right? You can see on the compound interest, I've got a significant more amount of money than I would have if I put it in simple interest. So compound interest is actually better if you've got it in a bank. If you owe someone else money and you need to pay an interest on that, you would prefer simple interest because you don't want to pay as much. So that's the idea. Compound interest takes into consideration how much money you have in your account. So, for example, same 10% per year. Let's say I've got $100. Sorry, my first year, second year, third year, fourth year, fifth year. Sorry, gosh, I can't count. Sixth year. My first year, we'll still have $100, right? But after that, I'll end up with 110, and then I've got plus 10, so 120, 130, 140, 150, 160, right? That's my simple interest. So I should write simple interest is in black. Interest. And then I've got my compound. So I still start with $100, except instead of adding 10% of how much I put in every single time, I'm putting 10% of how much I've got. So I start off with 100, right? And then I add $10 because 10% of 100 is 10, right? So I added 110. Now, instead of saying, well, what's 10% of 100? I'm thinking, what's 10% of 110, which is my last entry, right? So my last entry, 10% of 110 is 11. So I end up with 110 plus 11, and I end up with 121. Now, you can already see I've got $1 extra. Now I'm going to keep going. What's 10% of 121? Well, it's 12.1, but let's assume 12 for now. Now I add it to my original one before, 121, and that gives me 133. So and now I've got $3 more than I did before. Let's keep going. What's 10% of 133, sorry, which is about 13. 13 plus my last amount, which is 133, gives me 146. Let's keep going. It's about 15, so let's add that on. So 161, and then 10% of 161 is about 16. So add that on, 177. So you don't have to follow along, but you understand, you can see that there's a difference. With my simple interest, which is on the left, after 6 years, I ended up with $160, versus with compound interest, I ended up with $177. So you can see that the amount you increase by gets more and more and more, right? Rather than a simple interest, which is a straight line, as you can see from our diagram over here. So that's the idea with compound interest. We're trying to add an amount of money or percentage of money to the amount that we can slowly add more and more and more depending on how much money we have. Okay, so the formula for compound interest is A equals to P bracket is P times bracket, it's 1 plus R to the power of T. Okay, so 1 plus R to the power of T. Now, we could probably rewrite this to make it easier. We'll go with writing 1 plus R over 100 to the power of T. Okay, so as before, same thing as before, A is total amount. So that's my interest plus my principal. I'll go over that in a second. My P is principal, which is the amount of money that I originally started off with. And so that could be the amount of money I loaned to begin with, or the amount of money that I had to borrow to begin with. That's just a 1. Just to be clear, I'll write the 1 there, make it obvious. It's 1. R is the rate, and T is the number of years. And we use this formula to go ahead and calculate our compound interest. And you can use this formula in real life to calculate how much money you would have in a bank account if you didn't take any money out of it or didn't put any extra money in. So that's actually a real life formula. So just a reminder of last time, A is equal to P plus I. So in other words, the total amount, so that could be the total amount in your bank account, could be the total amount of money you owe, whatever it is equal to the original amount of money that you put in or borrowed, amount of money, plus the interest. So the interest accrued, or that just means like the amount of interest you owe, or amount of interest that you earn, right? So it's amount of interest plus your original amount equals to your total amount. Let's go ahead and use our formula in one of these questions. So first question is, find the total value of the investment if $8,000 is invested at 5% compounded annually for 4 years. So it's compounded annually, and I know my total value. I need to find the total value. My total value, that would be A. Now, if $8,000 is invested, right? If it's $8,000 invested, I know that $8,000 is my P, because that's the original amount of money invested, original amount. So I invested $8,000 at 5% compounded annually for 4 years, right? So I need to think to myself, well, 5%, that's my rate. And it's 4 years, and that's my T. So I go ahead and say, well, my investment total, or A, is equal to, now using the formula, right, that's the one up here. So I'm going to write P times 1 plus R over 100 to the power of T. Now every time I see P, I'm going to put 8,000. Every time I see R, I write 5. And every time I see T, I write 4. Right, I'm just substituting the numbers. Okay, so I get A is equal to 8,000 times by 1 plus R, which is 5, divided by 100 to the power of T, which is 4. I put that in the calculator, so that's a calculator step. Calculator. And I end up with something like $9,724.05. Remember, because we're working with currency, so it needs to have 2 decimal places. Awesome. So that means we've ended up with $9,724.05 after investing for 4 years. And if I wanted to find the amount of interest I earned, because remember, I personally put in $8,000, I would say $9,724 take away the 8,000 gives me $1,724.05. That's how much money I've earned, but that's not what I'm looking for. I'm looking for the total value. So that would be A, which is this one over here. Okay, let's move on. After 6 years, a loan grows to $62,150. If the interest was compounded annually at a rate of 9%, what is the amount of the initial loan to the nearest dollar? So I need to find the initial loan. So that's P. 6 years, that's my time. My loan grows to $62,150. So that's how much money I now owe. So that's my A. Now it's compounding annually at a rate of 9%, so that's my R. Perfect. I'm going to rewrite the formula. A equals to P bracket 1 plus R over 100 to the power of T. Then I get A equals to, I substitute my numbers. So A was 62,150. So 62,150 equals to P, which is, well, I don't know what it is yet, so I need to find it, right? So let me just move that closer there so we don't get confused. So P times by 1 plus R, which is, where is it? Which is 9. So 9 over 100 to the power of 6, because it's 6 years. Great. So what's happened is, right now, it's P times by 1 plus blah, 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 blah. What I can do is I can put this section there, just that part, in the calculator, and we can divide both sides. So if I calculate it out, I get 62,150 equals to P times. Now I'm going to go ahead and get my calculator, and I'm going to put 1 plus 9 over 100, or in other words 0.09, and then I'm going to write it to the power of 6. So this part right there, just this part here, that is equal to 1.677. And so I can write that 1.677 here. I can divide both sides by 1.677. And from there, I get P equals to, now 62,150 divided by 1.677 gives me an answer of $37,058. And that's how I find my initial loan. To the nearest dollar. Yep, it's to the nearest dollar. Awesome. Let's do this question here. After 5 years, a loan grows to $45,250 if the interest was compounded annually at a rate of 6% per annum. So that's per annum. Oops. That's per annum, which means per year. Find the size of the initial loan to the nearest dollar. Once again, need to find my initial loan, which is P. Times 5 years. My loan grows to $45,200. So that's my A, because it grows to that amount. So I need, and my 6% is my R. So then I can go ahead and use the formula, which is A equals to P, sorry about that, 1 plus R over 100 to the power of T. Substitute A, so 45,200 equals to P, which is, I don't know, so I just write P, times by 1 plus R, which is 6, divided by 100 to the power of T, which is 5. And then I use the same thing, so I put this part in the calculator, put that part in the calculator, and I get 1.06 to the power of 5, which gives me 1.338. So I can divide both sides by 1.338, and I get 45,200 divided by 1.338 equals to P, and that gives me an answer of, divided by that there, equals to $33,776 to the nearest dollar, so I don't have to write any cents. That's it. That's how much I originally had to loan. Okay, so hopefully that makes a bit of sense. Best of luck.